If P of t is the size of population at time t, which of the that makes sense. Which of the following differential equation describes a linear growth, linear, in the size of the population? Okay, so I'm terrible. I'm terrible at drawing axes, but I'm also terrible with vocabulary words. So when I think linear, I think straight line, which is pretty reasonable. And what this is saying is, if this is, okay, I guess this should be time t, and this should be population with respect to time. And it says, which of the following differential equation describes a linear growth in the size of population? So what this is saying is, the population is rising linearly. If we looked at a picture of population versus time, we'd see a straight line. The reason I kind of overemphasize this, because a lot of people here are like, wow, it's super obvious. I know. It's really easy to get tricked in these sort of things. So if there's something, I don't know, along the lines of the rate of increase is linear, you could almost interpret that as the dp dt, the change in population with respect to time, is linear. And so you would actually get something that you have like an x squared equation. So what they're talking about here is describes a linear growth in the size of population. It's not the rate of growth, it's the growth is linear. So we have population, we have time, we have this graph. And the idea is, what sort of differential equation would describe this? And you look at this and you're like, okay, you could either say that, all right, this, P of t equals, let's say, 200t. The point here is you have t and you have population with respect to time. Therefore, dp dt would equal 200. The idea here is you have a straight line. This would give you a straight line, because that's similar to y equals x, or y equals 2x, or 30x, or whatnot. As long as it's just that x by itself, just to the power of 1, that's linear. So the derivative of that is just going to be something like this. Now, you might see something like this. That'd be exponential, because when you solve this, you get an exponential. This, if you solve that, p would be something along the lines of 200t squared over 2. This would just be more so, and that'd be more so as well. And so the idea here is just linear. So the trick to these sort of problems is to not overthink them. Draw a diagram. It's a really easy problem. You draw it out, you find the answer, you move on. And you're given about 2 minutes or so for these kind of problems. So if you can solve a problem in like a minute, good, go for it. Get that little bit of extra time. But don't see a problem like this and rush into it so quickly and try and, save too much time, because you'll make a mistake and it'll hurt you in the end. So that's how I do these kind of problems. Slow and easy wins the race.